In this tutorial, we'll practice completing the questions on homework number 3. Let's take a look. The first assignment is area of composite shapes, trapezoids, and triangles. So let's take a look at this first question. What is the area in square inches of the trapezoid below? So let's take a look at this question on a larger screen. A trapezoid has an area formula of 1/2 the sum of the two bases, so base 1 plus base 2 times the height. So it's very similar to the area of a triangle, which is this formula, half the base times the height. But because a trapezoid has two flat bases, then we have to add them together. Again, the formula for the area of a trapezoid is half of the sum of the bases times the height. So it looks like we can start our formula with the 1/2 because that's permanent. And now, instead of the letters B1 and B2, I'm going to input that information. So it doesn't matter which one is B1 and which one is B2, but I'll label them so you know which one I'm talking about. So the first base at the top is a nice round 8. But the second base on the bottom covers quite a large section. So I actually have 12 inches plus an additional 7.3. So this base actually has to be added together. So 12 plus 7.3 is 19.3. And now for the height. The height has to be measured perpendicularly, so that means I need that 90-degree angle. And so the height for us is 5. Now we can do this problem in parts, or we can type the whole thing into our calculator. But you have to write this on your paper at least, so you know what numbers you're going to type in the calculator. So I'm going to open my calculator here. And instead of using the fraction 1/2, I'm actually going to use the decimal 0.5. So 0.5 times 8 plus 19.3. Now I can add that together in my head, or I can use the parentheses button on the calculator and tell the calculator to add these two first. Use those parentheses so that the calculator does the correct order of operations. And then I'm going to multiply it by 5. So my final answer there is 68.25 square inches. 68.25 square inches. All right, so we used our formula, half the sum of the bases times the height. All right, let's take a look at this question. What is the area in square feet of the trapezoid below? Again, use the same formula that we used last time. So the area is half the sum of the two bases times the height. So base 1 is 14.3, base 2 is 6.3, and the height, which is where the 90-degree box is 8.4. Pick up your calculator and type the whole thing in. Again, I'm going to use 0.5 for 1/2, and I'm going to use the calculator's parentheses button to type this whole quantity. Or I could just add that quantity in my head. If I know 14 plus 6 is 20, and 0.3 plus 0.3 is 0.6, then I can just type that here. Or I can just type the math problem as I see it. 0.5 times parentheses 14.3 plus 6.3. Then don't forget to times it by the height, 8.4. Final answer, 86.52 square inches. 86.52 square inches. All right, let's take a look at this question. The grid you see below is in the shape of a rectangle. What is the area in square units of the shaded part? Well, in this problem, it looks like the shaded part is a triangle. A triangle has a formula of half the base times the height. There's only one flat base, this one here. There's only one flat base. So therefore, I have to find that measurement. From here all the way over to there can be counted using these boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the base is 12. The height is 1, 2, 3, 4, because that's a 90-degree angle. Now this measurement cannot be found because it doesn't follow linearly along the grid lines, right? If it doesn't follow exactly along the grid lines, it cannot be counted. So it looks like I have a triangle that is 12 long and 4 high. So the area is half the base. Half of 12 is 6 times the height, which is 4. So 6 times 4 is 24. Half the base times the height. So it looks like I have 24 square inches. Or units, I should say. All right, how about this one? This looks similar to the trapezoid formula we used before. Now for the second topic, horizontal vertical distance with a line plot. In this one here, it asks you to plot the points -4, 6 and -4, 2, and then determine the distance between those points. So on my graph, I'm going to go to -4 on the x-axis, +6 on the y-axis, and click once. A yellow dot will appear. Now go back to the origin and plot -4, 2. -4 on the x-axis and 2 on the y-axis. That is a vertical distance, and I can count that because it follows the grid lines. That is a distance of 4 units. We'll do the same here. Plot the point by clicking once, -5, 6. Plot the point by clicking again, -5, -10. And then count along these grid lines. All right, third section, area of a triangle on a coordinate grid. So we did this one so that we can count properly the dimensions of our triangle. All right, let's take a look here. Triangle MNO with vertices at M, 3, -9, which is here, N, 8, -3, and O, 2, -2, is drawn inside a rectangle as shown below. What is the area in square units of MNO? Now here we have a problem. If I were to trace this side here, I would not be able to measure it. And that's because it does not follow perfectly along the grid lines. So if I can't measure the base and I can't measure the height, right, which would be 90 degrees, if I can't measure those two items, then I can't get the dimensions of the triangle. But what I can do is measure the rectangle. What I can also do is measure these other triangles that are created that do follow the grid lines. So I'm going to outline them in different colors. So I'll outline this one at the top in red. And I will outline this one on the side here in green. And then I will outline this last one in blue. And by doing that, I can find the dimensions of these triangles. So this one has a base of 1 and a height of 1, 2, 3, 4, 5, 6, 7. And the red one has a base of 1, 2, 3, 4, 5, 6, and a height of 1. And the green triangle has a base of 1, 2, 3, 4, 5, and a height of 1, 2, 3, 4, 5, 6. So it looks like this one has an area of half the base times the height. So I'm going to do half of 6 is 3, and 3 times 5 is 15. And my red one is half of the base times the height. So half of 6 is 3, 3 times 1 is 3. And then the blue one, this one's a little tricky because taking half of 7 or half of 1 is going to be a decimal, but half of 7 is 3.5, and 3.5 times 1 is 3.5. Now, you might be thinking, why did I find the area of all those little triangles? Well, all 4 of these triangles, the blue, the red, the green, and the one we want to know, all 4 of them add up to the outside rectangle. And the outside rectangle is 7 inches long and 6 inches wide. So the outside rectangle is 42 square units. So if I take away this one, which is 3, then that's 42, take away 3. And if I take away this one, which is 15, then I take away a 15. And if I take away this one, I'm taking away a 3.5. Right? So my mystery triangle plus 3.5 plus 3 plus 15, all that has to add up to 42. So what I can do is I can solve this math using my calculator here and subtracting these numbers from 42. So let me get my calculator ready. So my total here was 42. And I'm going to subtract from that my 3, my 15, and my 3.5. And it looks like I get 20.5 is left. So 20.5 must be the area of this inner triangle. Must be the area of that inner triangle here. Oops. So let's type that in. Again, the number was 20.5. Awesome. See that? They color-coded as well. Again, count the dimensions of the whole shape, right? So the whole shape here is going to be this rectangle. Then you're going to calculate the base and the height of the triangles that are formed using the straight sides. Triangle 1, 2, and 3. That will help you to figure out that missing dimension. Again, you have to be able to count along the straight grid lines. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is a 5 by 5 square. And triangle 1, 2, and 3, you have to find their dimensions. Triangle 1 is 5 by 3. So 5 times 3 is 15. Take half of that. You get 7.5. Triangle 2 is 3 by 2. 3 times 2 is 6. You take half of that, and you get 3. And triangle 3 is 1, 2, 3, 4, 5 by 2. 5 times 2 is 10. Half of 10 is 5. So these are all of the dimensions that you know, plus the missing dimension has to make your 5 by 5 square. So figure out what that number is, and you'll be able to answer this question. All right. Perimeter, numerical. So we have a crazy shape here. They're asking you to find the perimeter of the figure below in meters. You take all of these numbers, you add them up, you'll find your perimeter. Maybe see if you can find a shortcut. Looks like I have several repeating numbers. So 2.7, another 2.7, and the rest are 4.4s. So it looks like I have two 2.7s plus 1, 2, 3, 4, 5, 6, 4 by 4, 4.4s, and I can type that into my calculator to find the answer. So it looks like I have 2 times 2.7s plus 6, 4.4s, oops, parentheses, and my answer is 31.8. Easy and simple. Now, for this question, it tells you the perimeter is 73.8. So if I add up all of these numbers, then all of those numbers, once I add them all up, add all of those numbers up, plus my mystery number, I should get 73.8. So I have to figure out what all those numbers add up to so that I can subtract that number from 73.8 and find my missing dimension. And that is how you complete homework number 3.